Welcome to the first dev demo for SignRoom.io. I'm Sean Carden, the protocol architect behind SignRoom.io and the founder of Stateless Research. Today we're going to show off the SDK version 1.0 and how does that fit into the ecosystem of SignRoom. So, like I said, we are announcing the version 1.0 SDK on our website. You can see that there's a new section that talks about TypeScript SDK for managing end-to-end encrypted multi-sig ceremonies. You can handle the room lifecycle, PSBT merging, and audit trail generation programmatically. So we're going to go through this today. You can view this on NPM. We're going to go through the examples and read the docs as well. So let's get to it. The SDK in NPM, you can see that we have deployed the SDK. There's installation instructions, quick start, core APIs, going through the room initialization. It shows you just some example code. So what we're going to do today is we're going to go through this line by line and actually create a multi-sig ceremony and see how it interacts with SignRoom. But before we actually go through the code, I just wanted to talk about the different architectures and how does the SDK fit into SignRoom. So today we have the current public site architecture. So we have our users, which are the public users. They all go to signroom.io, which is an Angular client. This Angular client has now been unified with the SDK. So the Angular client uses the software development kit that you can programmatically use separately now. This SDK calls to the public hosted blind relay, the Cloudflare worker object, essentially allows you to interface with the blind relay. So the Angular client just calls the SDK, which interfaces with the blind relay. There's also the SignRoom embed, the web component, which is an iframe interface over signroom.io. So when you go on to the signroom.io site, you can actually see that we also have the web component demo here, and that's what relates to this. And also SignRoom embed is actually an npm package, which again shows you how to install pointed to your SignRoom client, and essentially allow you to actually listen for events. So we're going to go through the next part of this. So that's the public infrastructure. So with this for enterprises, what you can do is you can white label it. So you can purchase a license uh, from us, and you can white label the UI and self-host it. So you would have a skin site. So you would have your own skinsite.com, whatever you want to call it. Right now we had signroom.io, but you could have your own branded white labeled signing room. That would also have a private hosted blind relay, the worker object. And essentially what you can do is your developers can actually programmatically interface with your blind relay, which then causes the white labeled UI to update as well, which we'll kind of see later. The next thing you might want to do if you're an enterprise is you may have an existing dashboard. So if you have an existing dashboard and an existing application, what you could do is you could have the skinned white labelable client, the Angular client that it's branded. And what you could do is you still have your private hosted blind relay, and your software development kit for your developers to actually interface with this. But you may want to use the SignRoom embed, and this is where you use the web component embed framework to embed the iframe widget into your existing internal dashboard. You would listen to events emitted from the SignRoom iframe. And essentially what you do is you'll combine that with your own internal dashboards, authentication or account info, and you aggregate them together and you would put them into your SIM systems or your data store. So you can store exactly which users logged in and what they were doing in each room. The other thing you can do is actually, now that the SDK is released, you can actually have a complete custom UI. You don't actually have to use the Angular app. You could have your own skinned version of whatever. You can have a wallet. You could have, if as long as it's TypeScript compatible, then you can have your own custom wallet, your own exchange. You can programmatically call the SDK, which would then call your private hosted blind relay. And you would have your own custom backend in your exchange or your mobile app essentially. And what you can do then is you can aggregate that information coming out with the events from the SDK, your accounts, and everything else, and you can store it in your data store, your SIM systems there as well. So now we're going to go into the code. Okay, so here we are in the code, and we basically have a package JSON. Um, in here, it's important that you have your package JSON, you have your type module because of how the SDK is packaged. It's packaged with the new NPM modular way of doing things. So if you want to have TypeScript and a nice IntelliSense, then setting this to module is a good idea. You can see that there's a start. We do a tsx index.ts file. So this is where we're going to be writing our code, uh, which we're going to start now. And I've already got my dependency set up for signroom.sdk using the latest tag. Okay, so let's jump over to the index. So the first thing we want to do is we want to create a console app. So we'll need a run demo method. So we'll create that with a little async function because it's going to be asynchronous. And we have a catch there with the error. And then we need to start to import our libraries. So the first thing we do is import the Sign-in-Room SDK and the Sign-in-Room client. We're going to be using RxJS with some filters, pipes, and takes. We're also going to be using the read line, right? So we're going to be using that for a little console app controlling when we actually move to the next step. So we add in a little console error just to output errors, and then we will add in our read line, creating our interfaces, which we will use to control the app, right? And then we also close it at the end as well if we catch an error. So the first thing we do is we need configuration. So the first thing we have is the API URL. So the API URL relates to the worker, right? That's the blind relay. So as we start out here, we've got the three terminals, one in the Sign-in-Room SDK demo, one in the Sign-in-Room main um, GitHub folder. And what we'll do is we'll boot up the front end, which is running npx nx run client serve configuration development. And we will also boot up the worker, which is in Sign-in-Room apps worker. So we'll do npx wrangler dev, and we'll have both these things booted up. So now you can see that it's booted up in port 8787, which relates to the API URL, and the front end will be, the Sign-in-Room front end will be on localhost 4200. So that's the next thing we need. So we're basically now we've started to worker, relay, and the UI. We've got the configuration set up. Next, we need PSBTs. So I've just hard coded these PSBTs in today for the demo. So there's an unsigned PSBT, and then we have Alice's, Bob's, and Charlie's. So each one will be signed by each the individual users, and we'll be using unsigned PSBT to create the room. That's generally how we would do this. We also have an input and an output. These are already set in the PSBT that I'll be using today. So it's just going to demonstrate how we actually whitelist these and show how to do that programmatically. We also will set the quorum threshold. So the quorum threshold is, this is going to be a 3 of 5 multisig. So we're going to basically set that to 3. So we need at least 3 people to sign before the threshold is met to finalize. And next we will create two little helper methods. One will be waiting until we press enter for the step, and the other one will just be a prompt header to allow us to kind of visually show in the logs quite easily where each section ends. So we'll move on. We'll start out with printing the header, Signing Room SDK, programmatic integration demo. We'll be printing out the target relay API, so we'll print out which relay we're using, and then we'll print out the walkthroughs complete. So let's start with the first section. So section 1 is initialization and room creation. We do a little wait. And this is a coordinator in charge model, which means the coordinator is the only person who can actually finalize the transaction. You would need to have the admin permissions as a coordinator to actually finalize the transaction. So what do? First thing we do is we new up a new signing room client. We give it the API URL, the worker, the blind relay URL, and we basically say this is a coordinator client, and we call the create room and join. The create room and join takes basically a PSBT, which is the unsigned PSBT. The network, Bitcoin is mainnet, testnet, and signet. We'll be using signet today, and then the room name. So we're basically starting it up with unsigned Bitcoin transaction. The signet is the what network we're using, the test network. And today we're going to be starting the room up with the name SDK Vault, which we'll rename 3 of 5. And what we'll do is we'll print out each of these things. So what's returned is a room info object, which has the room ID, the encryption key or the decryption key, and essentially the encrypted admin token, which is what is necessary to have if you want to be a coordinator. And then we'll basically print out a live URL. So coordinator.getRoomLink. It will basically use the localhost 4200 and combine it with the encryption key if we set it true. So whether it includes the key or not, true or false, we're doing this for a demo, so we'll just say yes, we want that. And then we basically update some of the room metadata. So we call set room name. So we'll be renaming the name to a Q1 settlement approved from SDK Vault. And then the coordinator will set their display name as the room admin, right? Once we do that, we'll console log out, metadata applied successfully. So we'll save this and we will run npm start, and you can see it's running our code now. And what we'll do is we'll run the room initialization complete, so you can kind of see what's output here. So we got a room ID, the encryption key, encrypted admin token, and then we can monitor the live UI. So if I click into that, it should open up signing room, and we're inside the room. And you can see that the room is called Q1 settlement approved. You can see that we have 24 hours left. There's the room admin that we created, and there's myself. And you can see that there's 5 signers waiting to sign, and we have the inputs and outputs. Okay, so now that we've ran the first phase, let's move on to the next step, programmatically guest joining. So we print our headers for this next section. And what we do now is we create a client for each of the signers. So Alice client will new up a new signing room client with the API URL. The client will join a room. It will provide the room ID and the encryption key. Alice will then set the display name to Alice, and we will console log out that they joined the room. We will do the same thing for Bob, create a new client for Bob, join the room, set the name, print it out. Same thing for Charlie. So let's save that. And what we'll do is we'll run this again, create the room, we'll join the room, And what you'll see is we will run the second part now, which is enter to execute to guest joins, and you'll notice that they will join and you'll see this increment. And we'll also, okay, so Al's joined the room, Bob joined the room, and Charlie joined the room. And we can check here, and you can see that Alice, Bob, and Charlie have now joined the room, and they've labeled themselves as well, right? So we've done this all programmatically. Great. So let's move on to the next step. Address approval and room locking. So this is the OPSEC section. So next, we'll print out the header for section 3. And what we'll do is we'll console log out whitelisting the input. So we'll use the coordinator again. Again, this is a coordinator basically action that can only be done by the coordinator from the UI and the SDK. So what they'll do is to update the whitelist for the input. We'll provide the input up above the address. We'll also do the update whitelist for the output. We'll pass that through. And you can also remove. So if you've added, you can revoke a whitelist as well programmatically if you set that to true. And then what we'll do is the coordinator will lock the room and set it to true. So once the room is locked, no one can get access to the room, even if you've got the link. So basically, even if you have the decryption keys and the room ID, you won't actually be able to get into the room. So once all the kind of like signers come together, you can lock the room, and essentially there's no way to actually get access to the room. So let's save this and we'll see what this looks like. Okay, start. Okay, we create the room. We've seen before. Now they've joined the room. And then what we'll do is we'll look at, so you see when the room locks, this will go orange. And we'll also see that this programmatically whitelists as well. So here we go. So it whitelisted the inputs and outputs. This is went green. The input's green as well. And it says engage in the room lock. So the room lock is here, it's orange. So even if I wanted to go here and enter, it will say access denied because they've locked the room. You can't even get in, even if you have the decryption key. Okay, so stop that part. Next section, what's next? So next is the event listeners and signature uploads. So the first thing we need to do is we need to listen, the coordinator listens on the event signature received. So this is, it exposes a number of events. This is one of the main ones that you would listen to for signatures. And essentially what we'll do is we'll print out the signature received from the event, the total amount of signatures received, and the total signers that comes from the event. The coordinator then can get the remaining. This is a little helper method. They basically, you pass in the quorum threshold and it'll say how many is expecting left. Essentially, if the remaining is greater than 0, then it will print out waiting for so many more signatures. Okay. Next is if you wanted to say, if you're doing this programmatically and you wanted a human in the loop, so not just an AI agent or a bot, essentially what you can do is you can always have a human come in. So this is a little pattern, an example here where you do signature received. We filter for the payload to have 2, so because it's 3 out of 5, right? And what we'll do is we will create an alarm to say 2 signatures have been collected, paging a human in the loop for final review. You might at this point then send an alert to someone on Slack or Teams or whatever, and say you need to go and approve the final signature or review what the bot is doing, right? Once that happens. So the next thing that we do then, these events have been set up. So we've set up an alarm, we've set up signature receives. We basically wrap this part in a promise because we're in a console app and we don't want it to run on through to the end. So essentially we wrap it in a promise, and then we also have a threshold met. What we'll do here is this is another event. Say once the threshold is met, we want to do something, right? So again, we're just listening, we're subscribing to the event, and the event will be printed out threshold met, the signatures received on the thresholds, and then it will resolve once it gets here, and it means that it can move forward through the rest of the console app. All of these events are now set up. So we have the threshold met, we have the signature received, we have the actual alarm as well. So now what we need to do is for each of the clients, we want to extract the fingerprint from the signature. So that's a hardware fingerprint. So essentially Alice or the signer fingerprint. So Alice assigned PSBT, it will basically say, right, give me Alice's fingerprint. We will set the signer label on the UI. So if you want to call Alice's cold card, it could be Alice's cold card. Maybe you have your own referencing. And then you can basically push Alice's fingerprint and signature. So you can push Alice's signed PSBT. It's not the unsigned one, it's Alice's signed one and Alice's fingerprint. And I'll upload the signature in real time. We do the exact same thing with Bob. And what we do in the last one, we do it with Charlie as well. Same thing. And then let's save that and see what that looks like. We start, go into the room. And what we do is they're added into the room. We then lock the room and approve the actual addresses. And now we set up the listeners and we execute the sign-in, which you've seen in real time. And you can see that the events have fired. So triggering participants to upload signatures. So set Alice's, this is her fingerprint, this is Bob's fingerprint, and this is Charlie's. And then what we can do is you'll see that the events fired where the signatures are received and it's increasing, and it also shows you how many it's waiting. And then the alarm fired. They say that signatures were collected, paging a human in loop for the final review, and then the signatures received, right? And the quorum threshold was met, 3 of 3, right? So stop that and we'll move on to the next step, which is interesting. This is the finalization of the transaction. Once all the signatures have been aggregated and collected, the coordinator can finalize. So the coordinator finalizes the transaction, calling .finalize transaction. We print out the hex, a partial of the hex just for the demo, and the transaction ID. Then we get the forensic audit log. This is the events. It's not the full log. You can't get the full log, but this is just the events aspect of it. They print out the events. And then you can also call requesting the integrity report. So this is brand new. We create a cryptographic seal. So we combine the hex with the audit logs. And what we do is we hash them. And essentially it means that the audit logs, it creates a cryptographic seal, an anchor that says this is verifiable. So essentially the audit log that was produced and the hex are combined together, and you can reproduce that over and over again, and it will give you, and you'll see the actual integrity anchor. And then what we can do is verify the integrity as well programmatically. If you have the anchor, you provide the anchor, it will go and grab the CSV and grab the transaction ID, and it will allow you to verify whether it's valid or not. So that's important for compliance or auditing. So to make sure that no one actually, everything that happened in the events actually happened in the room, and that is tied to the hex and the transaction ID, right? So let's see what that looks like. Okay, so let's join the room. And what we'll do is go to next. So now they've joined the room, operational security, and I'll just add myself in here as well. I'll name myself. So I am Sean. Okay, and then what we do is we'll go through here. They're signed programmatically, and now we're about to finalize. Okay, so let's see what happened. We finalized. It gives a partial of the hex. It gives our transaction ID. It generated our audit log. So this is the CSV format. This is the format that you would use if you wanted to verify the cryptographic seal, which we'll see in a second. But it goes through and it shows you exactly what happened. And essentially, what you can do is see here. Here's your SHA-256 anchor, right? This is the thing that I just said. When you combine the audit log CSV with the hex, then you get this anchor, which means you can always verify that it is in fact this document relates to exactly what happened in the room. And then we just print out whether it's valid, right? So what's interesting here is if you compare the seal, so if I download the audit log and I save this, and if I just bring this up really quick, this is it. So you can see that if I just jump back to Chrome, so you can see that this is the cryptographic integrity seal. And it shows you the formula here as well. And you can see that it's A32948. And if I just transition back here, and we see that this is A32948. So they match exactly. And that's what I'm trying to say. The SDK and all the UI and everything is in sync. So let's stop that. And we'll move on to the next section, which is error handling. So there are some times when you might want to catch errors, just for your own kind of how to actually do this easily. I just wanted to demo it. So we'll create a latecomer. A latecomer is someone who tried to join when the room was maybe locked. So what you can do is you can listen on the protocol error event, and in the payload you can actually see type locked. So from the error, if it's locked, you can basically say, right, caught SDK error, server successfully rejected connection to locked room. And then what you can do is try and join the room. Okay, so you can try and join that room, but it will be locked. It's already locked, so it should catch this error and allow you to actually print it out. The next thing is like a hacker attempting to join the room with an invalid decryption key, right? Someone gets their hands on maybe the room ID and is trying to access this room. You can listen on the protocol error and you can look for access denied. So you can print out server successfully rejected, bad decryption key, right? So it might not even be a hacker. Maybe you're actually starting it up yourself and you realize actually you gave it the wrong key. You'll be able to listen for this error. And you can see that I'm trying to join the room ID, but with a completely fabricated, totally wrong key, 123, right? And we'll just see these errors print out. Okay, so we'll join the room and joined, we're listening, we're signing, and we've renamed them as well. We finalize it, get their integrity, and now the latecomer tries to get in. What do we see? The latecomer attempted to join the locked room, it printed out the error. Hacker tried to join the room as well with the wrong decryption key, printed out the error. Okay, great. Okay, last or second last section is recovery. So this is important as well. So again, if you wanted a human in the loop, right, and you're programmatically creating these rooms. Essentially, when you programmatically create the room, um, the bot is essentially the coordinator, right? So if you needed a human in the loop to maybe finalize the transaction, what you'll need to do is you need to create a new client, join the room, and then what we'll do is we'll just set the display name so you can see this client. But what you can do is call claim coordinator role. And what you need to do then is pass the encrypted admin token. The encrypted admin token was created at the very start once you create a room. So if you keep this safe, and you need to basically give a user admin permission to maybe finalize a transaction, you can do it programmatically through this call here, right? It allows them to become a coordinator. So let's just see what that looks like. Okay, so joining the rooms, sign in, pass in, cryptographic, and now we're going to execute the coordinator role recovery. We'll unlock the room and let them join. So now there's 6, and you'll see that we unlocked the room. The recovery client joined as a guest, elevated the privileges using the admin token, and now they're a coordinator. So if I just look here, you'll see that there's a room admin, there's me, there's Alice, there's Bob, there's Charlie, and there's the recovery client, and they are now a coordinator as well. So if you wanted to join that room as a guest and you had that admin token, you can go manually in here and you can assume the role and finalize the transaction. And the last piece of the demonstration is just a teardown. So what we do is we will close the room essentially programmatically. This should automatically disconnect everyone anyway, but it's always good practice probably just to call a disconnect method anyway, just in case. Clean up your connections, and that's it really. We'll close the room, so we'll just see that teardown where it closes the room. Closing the room is where it's wiped. The PSBTs, the encrypted PSBTs, and all the room state is wiped from the Cloudflare durable object. So that's what this is doing. We'll see that now. Okay. Get our signatures, passed, and then what we can do is destroy the room and disconnect. And that's it. And it will try and download your audit log. And then that's your room complete. And that is the end of the Signing Room SDK version 1 demo. Hope everyone enjoyed that. Don't trust, verify.